Hello, do you know why plants hate mathematics? It's because it gives them square roots. Welcome to another quest as we dive into number relatives. Wait a minute, did I just say number relatives? Yes, numbers have relatives, just like you and I. Have you ever heard the statement, like mother, like daughter? What do you think it means? The person making the statement would have probably noticed a character in a child that was also present in the parent, right? Numbers also behave the same way. Hence, a certain pattern can be used to obtain other numbers. Welcome to ratios. Now, if a number y is obtained by squaring another number x, the relationship between them can be written as x squared equals y. This will help us to get the value of y for any value of x by squaring x, or to get the value of x for any value of y by finding the square root of y. Or if a number q is gotten by halving another number p, the relationship between them can be written as p over 2 equals q. This is what ratio is all about. However, in reality, we don't need to indicate the actual relationship between the numbers. So, we use the ratio symbol, which looks like the punctuation mark called colon. This is pronounced ratio or to. Hence, in the previous example of x and y or p and q, we can write them as x ratio y or p to q. In mathematics, a ratio is a relationship between two numbers, indicating how the first value relates to the second value. So for example, if a class of 28 students has 16 boys and 12 girls, the ratio of boys to girls is 16 to 12. This means that there are 12 girls for every 16 boys in the class. Similarly, the ratio of girls to boys is 12 to 16, and the ratio of boys to the total number of students in the class is 16 to 28. Ratios can be shown in different ways. We can use the ratio symbol to separate the numbers as in A ratio B, or we can use the word to as in A to B, or we can write it like a fraction as in A over B. Any of these methods mean that we are comparing A and B. The numbers in a ratio can be any kind of quantities, such as the number of persons or items, or such as measurements of distance, weight, scores, and so on. But you should note that the numbers used are usually restricted to positive numbers. The trick with ratios is that a ratio does not change so long as we multiply or divide the numbers by the same value. So for example, 3 ratio 5 is the same thing as 18 ratio 30. This is because each number is multiplied by 6. Ratios can help us in multiplying or dividing things. Say for example, you need 3 spoons of tea and 2 spoons of milk to prepare breakfast for one person. So the ratio of tea to milk is 3 to 2. To make breakfast for 7 people, we might need 7 times that quantity. So we multiply the numbers by 7. And that will give us 21 ratio 14. Since the ratios are still the same, the breakfast should be just as tasty. We can also use ratios to scale drawings up or down by multiplying or dividing the numbers. You will learn about this and many more if you stick around for subsequent lessons. Bye for now.